Section 3.3 is about Venn diagrams. These are diagrams or drawings that can help us to visualize the sets and to understand the relationships between different sets. So these are referred as Venn diagrams. Venn is the name of the person who introduced these diagrams. Now, what are the Venn diagrams? The Venn diagrams are diagrams that consist of circles or represent sets as circles. And we usually have universal set U. That's the box here. That means all of the elements under study. And we have, so that's called universal set. So we have large, very large set or a larger set called universal set. And we have subsets of that set. For example, the set A and the set B. These are subsets. As you can see, we use the box or the rectangle, and we call it U, or we write U here, here, or here, or sometimes inside the box here. So this means this is the set of the universal set, all elements under consideration. But here we have subsets of this universal set. For example, the set A and the set B. So sets are represented as circles, and the elements are inside these circles. For example, here and here. And sometimes we have, they overlap. The sets sometimes overlap. For example, here sets A and B overlap, and so we can find sometimes some elements. And sometimes they don't overlap. So if this is the universal set, sometimes the set A does not have any elements in common with the set B. So the elements of A are completely different from the elements of the set B. So these representations are called Venn diagrams. These are very helpful to visualize sets and to understand the relationship between these sets. Now, if we have something in common here between A and B, we call this intersection. And the intersection of the two sets are the common elements. Because inside sets we have elements, and the common elements will be in this part where the two sets overlap. And the union, if we put all of them together, we call this union. So these are illustrations of that are called Venn diagrams. For example, if we have three sets, let's say we have the set A, the set B, and the set C, and we assume that those have some intersections, some elements in common. So if we want to find A union B intersection C complement, let's use the universal set here. And we first find A union B. A union B, let me shade this region. A union B, that means all elements in A or in B or in both. So this is A union B. All elements in A or in B or in both. Now, this intersects the complement of C. Complement of C, that means all elements that do not belong to C, but belong to the universal set. For example, if this is the representation here, this is universal set, this is the set C. What is the complement? The complements are elements that are outside the set C. This is the complement. So complement everything that does not belong to the set C, but belongs to the universal set. Now, we want to intersect this with complement of C, everything outside C. Outside C, let's shade this region. Outside C, that means here. So this is everything outside C. Now, the intersection means the union means everything together, and the intersection is just the common elements. So the common elements between the union, the shaded region, with the complement, the shaded region here, with the complement, everything outside C, this will be the region here. Let's start to erase. So it will be everything here inside the union, but not in C. So this shaded region, it represents A union B intersect C complement. So as you can see, Venn diagrams are very powerful. And let me give you another example on the complements. For example, it's very similar to the previous example or illustration that I showed you here. If we have the set B, this is the set B. What is the complement of B? Let me write B inside the set. What is complement of B? Complement of B is here. It's outside the set. It's everything outside the set B. This is the complement of B, as you can see. Now, the set B, if we add, this is union, that means we add elements together. If we add the complement of B, that will give me the whole universal set. So the universal set consists of the set and its complement, everything inside the set and everything outside the set. And the intersection, we talked about the intersection. The union, for example, if you have two sets and you want to find just the union of A and B, if this is A and this is B, what is the union? The union is all elements of A and all elements of B. If there is an intersection, that's fine. We just shade everything here. Good. So we have different situations, different cases, but as you can see, the most important thing in this section 3.3 is to realize the importance of Venn diagrams and to use them to make illustrations and understand the relationships between different sets. Now, the other notion here is the cardinality. What do we mean by cardinality? By cardinality, we mean number of elements in a set. And we usually use this notation. As you can see, it's very similar to the absolute value, but absolute value comes with functions or some specific numbers. But we can use another commonly used symbol or notation, n of A, number of elements of A. So n of A, let's use this notation. N of A, this is the cardinality of A. That means number of elements of the set A. Let's take an example. A survey of 200 people are asked, what beverage do you drink in the morning? And offers choices, tea only, coffee only, or both. So let's represent this using Venn diagrams. We have the first set tea and the second set coffee, C. Let's denote it as C. And both, because we have some intersections, so we make them overlap here, because both of them, tea and coffee, can be a case. Now, suppose 20 reports tea only. 20 only here. I can't write it here because that means here it means in common. They have tea and coffee, but since it's only tea, 20, that means it's here, it's just tea. And 80 just coffee, so we write it here, only coffee, and we have 40 report both tea and coffee, so we put it in the middle. They overlap. Now, the question is, how many people drink tea in the morning? Now, we have 20 drink only tea and 40 drink tea and coffee. So number of people who drink tea is 20 plus 40. So this is 20 plus 40, and that's 60. How many people drink neither tea nor coffee? We have 200 person. So 200 people, and the people who drink tea or coffee or both of them is 140. So what is the complement? We have 60. 60 who do not drink tea or coffee in the morning, because the total number is 200. And so the answer here is 60. Now, let's use some properties of cardinality or cardinal numbers. So cardinality, n, number of elements of the union, that's number of elements of the set A plus number of elements of the set B minus the intersection. Number of elements of A complement is number of the elements of the whole universal set minus number of elements of A. So let me show you what do we mean by this. If this is the universal set and we have the set A here. Now, the number of elements of the complement, this is the complement. Everything outside A is the complement of A complement. Number of elements of A complement is number of elements of the universal set, all numbers, minus number of elements of the set A. This will give me A complement. Good. Now let's take another example. We have the example here. Suppose set A contains 48 elements, set B 56. So let's draw Venn diagram. This is the universal set, and we have set A and set B. I can write A inside the set or above the set, near the set. That's fine, as long as we distinguish between the sets A and B. So contains 48 elements. Set A contains 48 elements. Set B contains 56 elements. If sets A and B have 25 elements in common, so we have 25 in common here in the middle. Now, what is the total number of elements in either A or B? Now, before that, if we have 25 in the middle, that means in both A and B, and we have 48 in A. So we need to subtract this from 48, and that will give me 23. Those are the elements of the set A, but not in the set B. Also, we have 56 in set B, but we already have 25 here in common with A, so we subtract this from 56, and that's 31. Okay, now what the question is, what is the total number of elements in either A or B? So what is the total number in either A or B? Now let's think about this for a second. Think about it. See how to find that number. As you can see, we need to use one of the properties here. We can use the first property because the first property gives me number of elements of A or B for both. So number of elements of A or number of elements of B is number of elements of A plus number of elements of B minus the intersection, A and B. This simple is read intersection. This is union. If it's open up, it's union. If it's open down, it's the intersection. Good. So we use property 1. And now this is number of elements in both, in either A or B, because the union, let me write it here. This is union, and it's usually read as OR. And this is the intersection, and this is usually read as AND. So we have the keyword OR and AND, either A or B. That's why we used union, because it's the word OR. Good. So number of elements of A is 48 plus number of elements of B 56 minus the intersection 25. And we compute this. We have 48 plus 56 minus 25. You can either use calculator or you can do it by hand. So let's compute it here. 48 plus 56 minus 25 is 79. So that's the total number of elements in either A or B. Now let's do one more problem.